to Finance Applications Part 1. Here we're going to look at the basic formula for simple interest, accumulated amount compound interest, present value of compound interest, effective rate of interest, and we'll also look at accumulated and present value when interest is compounded continuously. So we've got 6 examples I'm going to work through in this video here. Let's begin with example 1, which asks us to find the accumulated amount at the end of 10 months on a $200 bank deposit paying simple interest at a rate of 7% per year. All right. In order to calculate simple interest, what we do is take the amount of the principal, in this case $200. So we'll type that into our calculator. And we multiply that by 1 plus the rate times the time. In this case, our rate is 7%, or 0.07 in decimal. We're going to multiply that by the 10 months, but we have to be careful here because our time has to be in years. So we're going to take 10 in this case and divide it by 12 because 10 months is 10/12 of 1 year. All right, and what happens here is the 200 times the 1 when we do this distribution gives us our original $200, and the $200 times the interest rate times the time gives us the interest. So we end up taking the principal plus the interest to get the total accumulated amount. If I pressed enter, in this case I get $211.67 if we round that to the nearest penny, since these are dollars. That means that we started with our original principal of $200 and over the 10 months earned $11.67 in interest. In example 2, we're asked to find the accumulated amount at the end of 3 years on a $500 bank deposit invested at 5% per year, compounded monthly. All right, you know you're going to have compound interest when you see some form of the word compounded, compound, compounded, compounding, etc. That's your clue. If you don't see anything like that, you're not told a compounding period or frequency, then that's a good clue that you have simple interest even if you don't see the word simple in the problem. All right, our formula here is to take the principal, which is $500, and then we multiply that by 1 plus the interest rate, 5%, which in decimal is 0.05, divided by the number of compounding periods. So we're finding an interest rate per compounding period. Then we close the parenthesis and we raise that to a power, which I'm going to put in parentheses because we're going to have a multiplication going on here. We take the number of compounding periods in 1 year and multiply that by the number of years. So we put 12 times 3 here. That is, there's going to be a total of 36 compounding periods over the 3-year period. If we press enter, the calculator works out to be $580.74, again rounded to the nearest penny. So after 3 years, our $500 is now $580.74. You can also think of this as having earned $80.74 interest over the 3 years. All right, I like to do this problem a second time, and I'd like to use a built-in feature of the calculator. If you press the apps key, which is kind of in the upper left of the calculator, right next to the math key, you'll get a list of applications that are in your calculator, and the first one should be finance. So you can either just press enter or choose option 1, and it brings up a number of different pieces here. What I'd like to focus on in this video is the TVM solver, time value of money. That's what all these finance formulas do, is they take money and they move it around in time and they give us equivalent values subject to some kind of interest schema, that is an interest rate and a compounding frequency, and we get equivalent amounts of money at different points in time. So I'm going to choose option 1 here. I'm going to get a screen that's going to ask us for a lot of the pieces of information that we plug into our formulas. The first thing it wants is n. N is the total number of compounding periods. So for the problem we're looking at, it is going to be 12 times 3, or 36. All right, so it's the exponent from our formula. The interest rate here is 5%, and you'll notice that it says I%. that means you can just type it directly. You don't have to convert it to decimal first. If you do convert it to decimal, you'll get incorrect answers. All right, present value is our starting value. Please remember that present and future value are relative terms. They don't necessarily mean that the money has to be in the present or in the future, but they're just relative. Present always happens before future. All right, so we have $500. That's our present value, and we'll enter that. For right now, we're not going to worry about the PMT. That's a payment button, and we'll talk more about that in part 2 and 3 of the finance applications. We don't know what the future value is. That's what we're going to be looking for. So we'll come back to that in just a moment. This P per year gets into the idea of payments per year and compound periods per year. In the calculator, we always want them to be the same thing. And in this case, we're compounding monthly. So we want to tell it that we're going to compound 12 times in a year. And we'll just leave payment at end. Remember, for an ordinary annuity, actually, I'll take that back. You don't know anything about an ordinary annuity yet. That's going to come up in parts 2 and 3, and we'll talk about that more there. So you can ignore PMT when it's equal to 0. Just make sure it is 0. If it's something else, please set it to 0. And you can also ignore PMT, end, and begin. If it is on begin, you should set it to end because that's what we're going to use it set on later in the course. All right, we've entered everything that we have. What we want is the future or accumulated value. So we're going to cursor back up so we're highlighted on that. We're going to press the alpha key, and we're going to press the enter key, which above it, in the same color as your alpha key, it says solve. That tells the calculator to solve for the future value or accumulated value. And one thing you'll notice as we go through and use this calculator is your answers will almost always come out to be negative. If you're familiar with accounting, this probably won't surprise you too much in terms of getting into the idea of credits and debits, but it's just the way the calculator works. You can ignore that negative when you see it. So in this case, if we ignore the negative, we have the $580.74 that we had before. So this screen here kind of has all the different financial formulas built into it. And you can plug in for different things. It won't necessarily solve for everything, but it does solve for an awful lot of things. All right, let's take a look at example 3. We're asked to find the present value of $6,000 due in 4 years at 9% annual interest compounded quarterly. We're going to use the TVM solver again. We could also use the present value formula that you have. All right, for n, which is our total number of compounding periods, we're going to have 4 years, and we're going to have 4 compounding periods per year. So we're going to have 4 times 4, or a total of 16 compounding periods. Our interest rate is 9%, and in this screen we type in just 9. All right, we're going to come back to present value. That's what we're trying to calculate, so I'm just going to leave that alone and enter through it. I've said we'll ignore payment for now. The future value is $6,000. That's the total that's going to be due in 4 years. What we're really calculating here is how much the loan is for initially, or what it would cost to pay off the loan right now if there are $6,000 due in 4 years at 9% annual interest compounded quarterly. All right, so we put 6,000 into the future value, and then since we have quarterly compounding, we need to change P over Y to 4, and that will automatically change C over Y at the same time. All right, we're trying to calculate present value, so we cursor back up. Again, we press the alpha key and the enter key, so we get to the solve capability, and there's our answer. Once again, we have a negative, but that's okay, just ignore it. So the present value is $4,202.79. All right, if you were given that amount of money today, and then you were told that you had to pay it back in one lump sum 4 years from now, and the interest was going to be at 9% compounded quarterly, you would owe $6,000. So that's what we're looking at here. Those are equivalent amounts of money at 2 different points in time, subject to the interest and compounding that you see. All right, let's move on here. And we'll go to example 4, which asks us to find the effective rate of interest corresponding to 18% per year compounded daily. All right, I'm going to quit back out to our regular screen here, so second and mode, and I'm going to clear out what we've got, and I'm going to go to the formula for effective rate of interest. All right, and in that case what we do is we use 1 plus, and then we take the interest rate in decimal form. 18% is the same thing as 0.18. We divide that by 365 in this case, since we're compounding daily. Close the parenthesis. We're going to raise that to the power 365, because in the course of exactly 1 year, there will be 365 compounding periods. And then we're going to subtract 1 from the result. All right, and I'm going to press enter. And what we'll get back here is the effective rate of interest in decimal form, 0.197164245. If we want this in percentage form, we need to multiply it by 100. So I'm going to press times 100. And just simply multiplying times tells the calculator I want to multiply by the immediately preceding result, or answer, ANS. Press enter, and we find out that it's 19.7%, or 19.72%, depending on how many decimal places you want to round to. That's the same simple interest rate acting for 1 year as 18% compounded daily is acting for 1 year. So you'd have the same result over a 1 year period. Doesn't necessarily work out quite as well over multiple years, but this does take a look at equivalencies over exactly a 1 year period. All right, next we have find the accumulated amount at the end of 15 months on a $1,000 bank deposit invested at 5% per year compounded continuously. All right, I'm going to clear out our calculate screen. And I remember that accumulated amount, under continuous compounding is going to look like $1,000. That's our principal, or our starting amount, times E to the rate times time. So we're going to take 0.05 as our annual interest rate. Again, we have to use it in decimal now. We're not in the TVM calculator. And I have to multiply that by the time. The time in this case is given in months, and I want it in years. So 15 months is the same thing as 15 twelfths of 1 year, or 15 divided by 12. So there we get that time. And I press enter, and I find out that the answer is $1,064.49, rounded to the nearest cent. In other words, compounding continuously, we earn $64.49 in interest over the 15 months. One last problem. We're asked to find the present value of $250,000 due in 30 years at 6% annual interest compounded continuously. And you'll notice on these two examples with continuously compounded interest, I am using the formula. We don't have a way to tell the calculator that there are an infinite number of compounding periods. You're kind of forced to the formula here. All right. But remember, you don't need to memorize the formulas. They're provided for you as part of the course, and you'll get a copy of them as part of your test. So make sure that you can choose the right formula, but you don't have to memorize them. All right. So to find present value with continuously compounded interest, we take the accumulated amount, in this case $250,000, and we're going to multiply that by E to the negative of the rate, which is 6%, or 0.06, times the time, which in this case is 30 years. All right, now we're going to press enter, and we find out that $41,324.72 is the answer. So just to give you a little bit of insight into what this problem could be, let's say that you purchased a home, a rather inexpensive home, and you paid or you got a mortgage as a result of however the purchase worked of $41,324.72. And your mortgage, for some strange reason, because they don't normally do this, has 6% annual interest with continuous compounding. It's that continuous compounding bit that's strange. And let's also assume that you never make a payment on it until the end of 30 years. So you're going to save money on your own, and at the end of 30 years you're going to have to pay off the original principal along with the interest. Well, your payment is $250,000, which means the interest that is racked up in the meantime is the difference between $250,000 and $41,324.72, or roughly $210,000 in interest. All right. One thing I encourage you to do as you work through the problems involving time value of money is to try to take some of the problems a little further than you're actually asked to. Try to figure out how much interest is earned. Try to make sure that you understand the meaning of the numbers at different points in time. Just spend a little bit more time with this stuff. Especially for those of you who are business majors, understanding finance can be a very useful tool, and it can help you make very sound decisions over time if you understand it fairly well. So I encourage you to do that.